All right, so let's start our second unit of the semester, and it's all about functions. So our first target here, we're just going to define what is a function. So a relation is a function if each input has exactly one output. So let's just talk about that for a second. So an input value is generally our x coordinate. That's what we think about our input. And then the other name we have for input now is domain, because domain goes with x. So for every value for x, there's exactly one output, there's exactly one y value or range. So let's take a look at this, kind of have a visual representation with a table. So this is a horizontal table, but it works the same way as a vertical table. And notice this first question is asking us a relation that is not a function. So what I'm going to do is go ahead and fill out some x values. And there's no rhyme or reason for these different x values. I just started at 1. And notice I do have 2 3s here, and I did that on purpose. So now I'm going to fill out some f of x. Remember, this is also y. F of x is the same as y. So now I'm going to fill out some different y values or outputs or range values. Okay, so this is not a function because of what's happening right here. Each input does not have exactly one output. The input value of 3 has 2 different outputs. It has 7, it also has 8. So why is this not a function? Each input doesn't have exactly one output. And in parentheses, I'm going to say 3 has 2 different outputs. All right, and now we're going to do a table representing a relation that is a function. So here I'm going to go ahead and fill out x values. Again, no rhyme or reason. Notice I didn't repeat any of the x values this time. And then I am going to fill out some y values. Now this one looks kind of tricky because it seems questionable that 2, 3, and 4 all have an output of 7. So that kind of makes it seem like it shouldn't be a function. But in reality, this is still a function because each input has exactly one output. It's just that each input sometimes has the same output, and that's okay. So again, this works because each input has exactly one output. And in parentheses, I'm going to say it's okay for several inputs to have the same output. Okay, so now we've looked at a function from a table, but we can also determine if a relation is a function from a graph. So that's what these last 4 questions are for target 1. So couple things here. I'm actually going to talk about the vertical line test, which is written at the bottom of your page. So the vertical line test, this is a visual test to see if each input has exactly one output. Okay, so what happens with the vertical line test is we imagine or we actually draw, whatever works for you, a vertical line. So here's my vertical line. And then what we're going to do is scan our graph to see if our vertical line touches our curve at more than one point. And as we go across this, this is a quadratic. As we go across, notice it only touched the quadratic at one point. So yes, this is a function. It passed the vertical line test. Now we have this circle, so let's try the circle. As I go across, notice, for example, here, it's touching the circle at two different points. That means this is not a function, and the reason is at this input value of -4, there's two different outputs. There's an output up here, and there's an output down there. So that is not a function. Continuing on to our absolute value graph, notice it only touches this graph at one point at all times. So yes, this is a function. And then we have this, what looks like a sideways quadratic. Let's take our vertical line. Come here. Whoops. Can't grab it. There it is. Take our vertical line, move it across. Just moving slow here. There we go. And notice it is touching at 2 points. So for example, right here, I could pause it anywhere really, but I'm just pausing it here. There's two outputs at the same input. So this is not a function. Oh goodness, having some trouble here. Bear with me. This is not a function. I do just want to mention that the vertical line test is not a mathematical reason to say that something is a function or not. So you can't say yes, it's a function because it passes the vertical line test. You need to go ahead and specify that you have a function because it has exactly one output for each input. All right, moving on to target 2. So now we're going to evaluate some functions. And so this looks kind of crazy, but really all we're doing on these problems is we are going to take this value in parentheses and we're going to plug it in for x in our function. So on this first one, I'm going to take the 2 and I'm going to plug it in for x. And you guys have done this so many times before. So when I plug it in and I simplify, I get -11. So same thing over here. On b, I'm going to take this value in parentheses and I'm going to plug it in for x. I'm going to plug it in for all the x's here, and then I'm going to simplify. So if I do 1/4 times 0 squared minus 0, that all gives me 0, and then I subtract 2, so I get -2 in the end. Alright, so if you look at C, this is what's called a piecewise function, and we're going to learn to graph these at the end of the unit. But to start off with, whenever we have a piecewise function, we really need to focus on the inequalities, okay? So we're going to have to make a choice. Does our input value, in this case 0, does it make the top or the bottom inequality true? So if I plug in a 0, is 0 less than 1 or is 0 greater than or equal to 1? Well, it's not greater than or equal to 1. That's not a true statement. So we're going to ignore that whole second line. So because it made the top inequality true, we're going to plug it into the top equation. So we're going to do 0 plus 3. And so our output is 3. So notice there we ignored the complete second half of that equation. And then we're going to start again once we have a new input value. So now we have an input value of 4. So I'm going to test that in the inequalities. Is 4 less than 1, or is 4 greater than or equal to 1? Well, 4 is not less than 1, so we're going to ignore that top because that wasn't true. The bottom was true, so we're going to plug in 4 for x in the second equation. And if I simplify that, I should get -7. Okay, so now on D, we have another piecewise function, but there's 3 lines, and so it's going to work the same way. You're going to take your input value, which is -4 in this case, and we're going to plug it in to all 3 of the inequalities. So is -4 greater than 3? No, it is not. The way I would read this second inequality is negative 4 in between negative 2 and 3. So think about a number line. And that is not true either. So it should be true on this last one. Is negative 4 less than negative 2? That's a true statement, so we're going to plug it into this last equation. So I'm going to do 3 over 2 times negative 4 plus 3. That would be, I believe, negative 3 once you calculate that. And then we're just going to start again on the second input value. So we have a new input value now of 2. So we're going to plug this in. Is 2 greater than 3? No, that's not a true statement. Not using that. Is negative 2 less than or equal to 2 less than or equal to 3? In other words, is 2 in between negative 2 and 3 on a number line? That's a true statement. And if you wanted to test this last one, notice that that is false. 2 is not less than negative 2. So we're going to plug it into this middle equation. If you go to plug into this middle equation, notice there's no x, there's no variable. So it doesn't matter what the input is, the output's always going to be 2 since that's the equation. So that's evaluating a piecewise function. So notice again, we're just always plugging in the x value and seeing what we get out for y. So now we're going to do this again, but we're going to use a bunch of functions. So if you look at these functions, we have different names. And so just kind of glancing around, this is the f function, the g function, the h function, so on and so forth. So they kind of have their own name. And that's why we use function notation, so we can have different names and they're not all y equals. So the first thing you're going to do is look at the letter on the outside of your problem, in this case f. Then you're going to find the f function. So I'm focused in right here. Now it says f of 3, so I'm going to take this input value of 3 and plug it in for x in this function. So 2 times 3 plus 1, that would be 7. On example B, it has a j on the outside, so I'm going to find the j function, which is this second graph. The input value is 2. So I'm going to find 2 on the x-axis, which is right here. And I'm going to actually make this a vertical line at 2. And if you notice where that bumps into our actual graph line, it's at that point, which has an output of negative 1. So again, just remember that I'm giving you the input. Your answer should be the output or the y value. So the next example has the letter m. And if you'll notice, this is the m function. So the input value, the x value is 2. So here's the x value of 2. We can see the y value that goes with that is 1. Now we have k of negative 1. So again, find the k function. It's over here. Our input value is negative 1. So when our input is negative 1, the output is 2. Our answer is always the y value. Alright, now we have the g function. So I'm looking for the g function. It's over here. Our input value is 4, so I'm going to plug in a 4 for x. And if I simplify that, I get negative 1. And then the last one we have is h of negative 2. So I'm going to find the h function, which is the first graph. Here's the x value of negative 2. So again, I just like to make a vertical line and see where it bumps into the actual graph, and your answer is the y value. So the y value there is negative 5. The last thing that I'm going to ask you to do on this target is to evaluate. This is a piecewise function again, so this is the graph. We looked at the equations earlier. I'm going to ask you to evaluate this. So this got cut off, but I think it's an f. F of negative 4. So again, just like we did in the graphs above, find your x value of negative 4. It's right there. Make yourself a vertical line. It hits the line right here. The y value is -4. Now it asks what's f of 4. So f of 4, here's the x value of 4. It hits the line right there. The y value at that point is 5. I do want to add one more example here just to show you something that could get kind of tricky. I want to talk about f of 3. So f of 3, the reason that's tricky is it looks like there's 2 points there. So what I wanted to explain to you is you always pick the filled in point. So I would never pick that point up there. So the filled in point has a y value of -2. So if you ever run across that case, just pick the filled in one. All right, our last target today is talking about identifying a linear, an absolute value, or quadratic function given an equation, a table, or a graph. So let's start with what a line looks like. So graphically, a linear function, it's just a line. Pretty simple. Algebraically, a lot of times we look for that slope-intercept form. And then numerically, which means from a table. And we looked at this in Unit 1, we're going to be looking for a constant rate of change. So we're going to calculate the rate of change, and if there's a constant one, we're looking at a linear function because that constant rate of change is known as slope. Absolute value graphically has a V shape. Algebraically, we have our variable x is inside absolute value bars. So variable inside absolute value bars. And numerically, so if we look at a table, the rate of change is constant, which makes it seem like it is a linear function. Rate of change. But I'm going to make a note here, but it goes positive and negative. And then our last function that we're going to be looking at in this target is a quadratic. Graphically, it's a U shape. Algebraically, x is squared. And numerically, it's a non-constant rate of change. Okay, so let's look at some examples here. We're starting with graphs, and so we're going to determine, is this graph linear, quadratic, or absolute value? So on A, it's a line. This is linear. On B, it's a V shape, so it's absolute value. On C, it's a U shape, so it's a quadratic. I always think it's easiest to do this from a graph. All right, so now from an equation. So notice we're using that function notation, so no longer does it say y equals, but that's okay, it's the same thing. So if I look at D, I'm noticing that this is in slope-intercept form, y equals mx plus b form, so this is linear. On E, I see that x squared, so it's quadratic. F, again, it's in slope-intercept form, y equals mx plus b. You could put a plus 0 to really see it clearly. So that's linear. And G, our variable x is inside absolute value bars, so this is an absolute value. Absolute. This is an absolute value function. All right, so now from the table, this is going to take a little bit more work. So we're going to be focused on the rate of change, which means we're going to be looking at the y column. So we're going to think about how much do we have to add or subtract to go from the first y value to the second. So in this case, I would have to go down 0.25 and down 0.25. Again and again. So I'm noticing a pattern here. And you see how it's constant? You're always subtracting 0.25 all the way down. This is a linear function. That's the constant rate of change, and this actually has a rate of change of negative 0.25. Okay, so let's look at I. Here, I'm adding 4 to go from the first to the second. I'm adding 4. So it looks like a linear function because I'm noticing that constant rate of change. However, look at this next shift. It's still a 4, but it becomes a minus 4. So this is what we have for absolute value. So there's still a constant rate of change. It's always 4, but it starts from positive and then goes negative. So this is absolute value. And then our last example, let's look at our rate of change here. So that would be down 5. This would be down 3. This would be down 1. And right off the bat, I can tell this doesn't have any sort of a constant rate of change. Anytime you see that, it is a quadratic. And those are your notes over targets 1 through 3.